The Sea Lamprey by Aaron Murray, Ben Brown, and Garrett Zimmer. We have decided to narrow our scope from quality of lakes in Ontario to the effects of the sea lamprey in our aquatic ecosystems in Ontario. The sea lamprey made their way into the Great Lakes systems through the St. Lawrence River and continue to be detrimental to the health of the Great Lakes. There have been many initiatives to control and reduce the sea lamprey population. We will be outlining the several control methods that have been put in place, as well as the lamprey effects and characteristics. We hope you enjoy, and thank you for watching. The sea lamprey became an invasive species in Lake Ontario in 1835, in Lake Erie in 1921, and Lake Huron in the early 1930s. They spread throughout the upper Great Lakes by 1939. The sea lamprey is part of the Petromyzota family. This family contains holotratic, parasitic, and non-parasitic species. They feed on the bodily fluids of fish. The main target were whitefish. The lake trout was the main predatory species. At the time, lake trout actually became extinct in Lake Ontario, Erie, and Huron during this period. Causes extinction in 3 other whitefish species. It is believed that the lamprey entered the Great Lakes through the St. Lawrence lowlands. Originally, lamprey came from the Atlantic Ocean. A woman named Marilyn Bell was swimming across Lake Ontario. Soon after being in the water, it became apparent to her that she had something attached to her body. It reminded her of a blood-sucking eel. She said it was to be 18 inches in length and a bloodthirsty predator. It had cut through her bathing suit, trying to suck out her bodily fluids. For many years, the lake's natural species could not be protected against the bloodthirsty lamprey. The lamprey swim up to fish and latch his or her nose onto the fish using its sharp teeth, drills into the body of the fish. The lamprey sucks the bodily fluids out of the fish until there is nothing left in the fish, and it is left to die. The average lifetime for a sea lamprey is estimated to be 11 years. The color of a sea lamprey is a gray-blue-black color, a metallic violet on the sides, shading to silver and white on the underbelly of it.
Flowhead barriers are used to regulate the control of species through a stream by the use of barriers, fences, and other obstructions. These specifically target sea lamprey while allowing other fish species to pass through. This reduces the possibility of sea lamprey migrating upstreams into other lakes. These barriers are very expensive to design, construct, and maintain, and are only used in situations with little other alternatives. There are several types of barriers used. One, for example, is an electric fence or barrier installed in an area where sea lamprey spawn. The electric barrier electrocutes the sea lamprey, killing them and ultimately decreasing the lamprey population at the spawning stage. These barriers are very effective and are being reviewed for use in areas where they are financially feasible. Since 1957, the lampricide TFM has been a main component of the sea lamprey control efforts in Lake Superior. The lampricide is applied in streams and tributaries and targets sea lamprey larvae, destroying them before they can mature into adult lamprey. About 175 Great Lakes streams have been treated on a regular basis with lampricides since their introduction in 1957. The initiative was brought forward by the International Sea Lamprey Control Program, and the TFM lampricide has little adverse effects for fish and humans. Today, sea lamprey populations are still being controlled through the use of lampricides such as TFM. TFM is registered with the U.S. Environmental Protection Agency. However, the use of lampricides is expensive and groups are looking into alternatives. The sterile male release technique was first used in 1991 up until 1999 in the Great Lakes to reduce sea lamprey populations. It employs the use of sterile males which are introduced into an aquatic ecosystem like the Great Lakes. The sterile sea lamprey are competitive with their non-sterile male equivalents and compete for potential female mating partners. When the sterile males mate with their female partners, it does not lead to an increase in population due to the fact that the sterile males cannot fertilize the female's egg. However, this technique is flawed because it is a lot more effective when the densities of female sea lampreys is higher than normal lamprey density conditions. Repelling invasive species such as the sea lamprey utilizes another technique to control their effects in the Great Lakes. To do this, they use decaying sea lamprey scents to repel them from an area. Michigan State University was at the forefront of this discovery and have discovered that sea lamprey do not like the smell of death and decay of other lamprey. They have created a scent product that is placed upstream of sea lamprey spawning areas, which causes the sea lamprey to repel and leave. This reduces the overall population and effects from the sea lamprey on the Great Lakes. The decaying scent technique is efficient in eliminating 90% of the sea lamprey population in a specific stream system.
Although early declines in lake trout abundance in the 1940s are suspected to have been caused by overfishing, sea lampreys are believed to be responsible for the very rapid decline in the later 1940s and 1950s. Lake trout actually became extinct in Lakes Ontario, Erie, and Huron, except for a few inlets in Georgian Bay and Lake Michigan. Lake trout is considered an appendix predator, which means the entire system relies on its presence to be diverse and healthy. Two factors contributed to the devastating effect of the sea lampreys. First, sea lampreys lacked effective predators. Second, the Great Lakes probably have as many miles of tributaries as many as the larval habitat of the native range of the sea lamprey along the Atlantic coast. Host fishes in the Great Lakes are much smaller than those attacked in the Atlantic Ocean and are more likely to be killed by sea lamprey attack. Between 40 to 60% of lake trout attacked by a sea lamprey will die from loss of blood. These attacks were a major cause of the collapse of lake trout, whitefish, chub populations in the Great Lakes in the 1940s and 50s. Sea lampreys attach to fish with their sucking disc and sharp teeth, rasp through scales and skin, and they feed on the fish's body fluids, often killing the fish. During its life as a parasite, each sea lamprey can kill 40 or more pounds of fish. Sea lamprey are so destructive that under some conditions, only 1 out of 7 fish attacked by a sea lamprey will survive. Sea lampreys have had an enormous negative impact on the Great Lakes fishery. Because sea lampreys did not evolve with naturally occurring Great Lakes fish species, their aggressive predaceous behavior gave them a strong advantage over the native fish prey. Sea lampreys prey on all species of Great Lake fish, such as lake trout, salmon, rainbow trout, whitefish, chubs, burret, walleye, catfish, so on and so on. USA and Canada harvested a total of 15 million pounds of lake trout a year, but by the 60s it was down to 300,000 pounds a year due to the invasion of sea lamprey. A couple fun facts about the sea lamprey. Sea lamprey are considered a delicacy in Portugal as well as in some parts of Spain. Lamprey may live in a stream as an amekisoti, which is their young stage, for up to 20 years before transforming into mature lamprey. To remove sea lamprey from either fish or humans, all you need to do is squeeze the lamprey right where it is connected at the head to the fish or the body, and continue squeezing it in a circular motion. Once you are all the way around, gently pull off the lamprey and you're all good to go.
As discussed in our presentation, sea lamprey are an invasive species that are affecting the Great Lakes ecosystems. The introduction into the Great Lakes of these invasive species can affect population dynamics, food webs, and cause economical losses. Without the proper control and removal methods, the invasive species has the potential to destroy a fragile, balanced ecosystem. For example, since the control and removal of sea lamprey, the lake trout population in the Great Lakes has rebounded and repopulated. This relates to our limnology class because it deals with an invasive species that has the potential for great destruction of freshwater bodies like the Great Lakes. Thank you for watching.